An important use of complex numbers is finding the square roots of negative numbers. Just as every positive real number r has two square roots, square root of r and negative square root of r, every negative number has two square roots as well. If negative r is a negative number, that means the square roots are going to be plus or minus I square roots of r. And that's because if I take I square roots of r and square it, I'd have I squared times the square root of r squared. I squared is negative 1. Square and square root cancel, so that would be negative 1 times r, which is negative r. So if I square roots of r squared is negative r, then the square root of negative r must be I square roots of r. That's a mouthful. And if I take negative I square roots of r and square it, we'll have negative I squared, not negative 1, negative I squared times negative r squared. Negative I squared is still going to be negative 1, because I squared is negative 1. The negative, we're just going to have two negatives, right? And then just going to be a positive. And a positive times a negative is still going to be a negative, so negative 1. And then square and square root cancel, so that would be r. And again, that gives us negative r. So if negative I square roots of r squared would be negative r, then the square root of negative r must be negative I square roots of r. So we're going to have two solutions when we solve negative radicals, right? Whether they're positive or negative. All right, so the first one, the square root of negative 1. We have two answers. Right, we have, I did read over that. So let me just read over that. Sorry. If square roots of negative numbers, if negative r is negative, then the principal square root will be the positive one. But there are two answers, right? If we're solving an equation, there'll be two answers, the positive and the negative. And for this activity, we'll find both the positive and the negative. All right, so square root of negative 1 will be plus or minus I. Square root of negative 16, right? So that is the same as the square root of 16 times the square root of negative 1. 16, of course, is a perfect square. 4 times 4, 1 4 comes out, 1 4 goes away. Square root of negative 1 is I. So our answer here will be plus or minus 4i. And then we have the square root of negative 3. Well, 3 is a prime number, but we could factor out the negative 1, which is a perfect square. So we have, I keep forgetting my plus or minus. We have plus or minus the square root of negative 1 times the square root of 3. Square root of negative 1 is I, and then we have the square root of 3. Let's solve an equation where we are going to need to take the square root of a negative number. Solve 2x squared plus 6x plus 72 equals 0. Now let's use completing the square. Right? Right, so our first step is to divide all terms by a. So that's 2. So we have 2x squared divided by 2 plus 6x divided by 2 plus 72 divided by 2 equals 0 divided by 2. So that's going to be x squared plus 3x plus 36 equals 0. Actually, you know, I should have made it. I wasn't thinking. I'm going to change this. I reserve the right to change this. Let's give ourselves an even number. Let's make that a 12x. If I make up the problem, I reserve the right to change it. Let's keep it even instead. Because it's just a tad easier to solve when b is even. All right, so let's make that solve in 2x squared plus 12x plus 72. And we divide by 2, we have x squared plus 6x plus 36 equals 0. Step 2 is to isolate the constant. So that's going to give us x squared plus 6x equals negative 36. We'll subtract 36 from both sides. We can do our next step right on the same line there. Don't forget we want to make this a perfect square, so add b divided by 2 squared to both sides. So that gives us 6 divided by 2 squared plus 6 divided by 2 squared. All right, so that's going to give us, on this side, x squared plus 6x plus 6 divided by 2 is 3. 3 squared is 9. Over here we have negative 36 plus 9. So now we're going to factor on one side and simplify on the other. Over here, when we factor, since this is a perfect square, it's always going to be half of b. So when it factors, it's whatever the sign of b is. So x plus or minus, and then b divided by 2. The thing you squared. And there's 2 of them, because it's a perfect square. So this would be an x plus 6 divided by 2, of course, is 3 squared equals. And then negative 36 plus 9 would be a negative 27. Take the square root of both sides. So we have the square root of x plus 3 squared equals plus or minus the square root of negative 27. Make that look a little nicer. All right, square and square root cancel, so this is x plus 3 over here. And then we can simplify 27. All right, that's 9 times 3. 9 is 3 times 3. And don't forget to multiply that by the square root of negative 1, which is just I. So the square root of 27 simplifies to 1, 3 comes out, 1, 3 goes away. 1, 3 has nobody. To 3 square roots of 3, and then times I. So that's going to be plus or minus 3i square roots of 3. Put the things that are out of the radical in front of the radical. And our last step is to solve for x. So subtract 3 from both sides. X equals negative 3 plus or minus 3i square roots of 3. And we have our answer. So the complex numbers allows us to solve every quadratic equation, even if we don't have real solutions. And in case you're watching this on the Nearpod and the video is blocked, that little black line is blocking you, let's just do that so that now when you pause, you can actually see the bottom of the notes. Okay. Now this is a little extra one. It wasn't in the notes, but if this is something that you don't feel strong in, you might want a sample, right, so that you can use for your notes. All right, we'll look at a couple more things, but we're almost done. You're looking at complex numbers. Now, one little important thing. Special care must be taken when in performing calculations that involve square roots of negative numbers. Although the square root of a times the square root of b is equal to the square root of a times b when a and b are positive, it's not true when they're both negative. So, for example, the square root of negative 2 times the square root of negative 3 is not equal to the square root of negative 2 times negative 3 is not equal to the square root of positive 6. That would be incorrect, because the square root of 2 is I square roots of 2. The square root of 3 is I square roots of 3. So you need to do that simplifying first. So simplify negatives first, then multiply. All right, so now that will give us, that does equal, so when you're multiplying a number times a number, you multiply the coefficient by coefficient, radical by radical. So you multiply the I times the I. And that would be true whether this was an I or this was a number, right? If I was multiplying 3 square roots of 4 times 2 square roots of, oh, I shouldn't do 3 square roots of 4. That's a perfect square. All right, so 3 square roots of 2 times 4 square roots of 5, all right, you would multiply the 3 times the 4 and get 12, and the square root of 2 times the square root of 5 and get 10, all right? And then you simplify if you could. That's 12 square roots of 10. All right, so this is going to be I times the square root of 2 times the square root of 3. So that's going to be equal to I squared times the square root of 6. And what's I squared? I squared is negative 1. So this is negative square root of 6. All right, so this, if you have negatives, don't just multiply them. Simplify those negatives first. Then you can multiply, because this is not the square root of 6. It's negative square root of 6. That's what that would be equal to. I think that's the end of my video. If this is a blank page, oh no, I have one more. This is the end of my video. All right, so if you need to pause, go ahead and pause, or I'll pause if you're in class. Otherwise, let's look at this one. All right, using square roots of negative numbers. So we want to evaluate our expression here. Square root of 12 minus the square root of negative 3 times 3 plus the square root of negative 4i, negative 4, thinking ahead, and express results in the form a plus bi. Our first step should be to simplify the radicals before we start multiplying and messing things up. All right, so square root of 12 is 4 times 3, and 4 is a perfect square. So let's rewrite that as 2 square roots of 3. Square root of negative 3 could be rewritten as we saw before, I square roots of 3. And the square root of negative 4 is going to be 2i. Now, here we are just simplifying radicals. We are not solving for anything. There's no plus or minus, right? So when there's a plus or minus when we're solving, when I'm just simplifying a radical, it's just simplifying a radical. All right, now, once we simplify the radicals, now multiply. And we'll just multiply using distribution. All right, so now the 12 is now 2 square roots of 3 minus I square roots of 3 times 3 plus 2i. And you can see that if we did plus or minus, that would be all confusing. Which do we do, right? And how many numbers do we get here, right? So if we're just simplifying, we're just getting a single number answer here. All right, so we're going to multiply 2 square roots of 3 times 3 plus 2i, and a negative I square roots of 3 times 3 plus 2i. So 2 square roots of 3 times 3, multiply the 2 and the 3 together. That's 6 square roots of 3. Numbers times numbers, radicals times radicals. And a number is anything outside a radical. All right, and then so 2 square roots of 3 times 2i is going to be 4i square roots of 3. So nobody else is inside the radical but that square root of 3. So he doesn't get to be multiplied by anybody. All right, and so now we have our second one. We have negative I square roots of 3 times 3. That's going to be negative 3i square roots of 3. Right? Multiply the 3 and the i together. And then negative I square roots of 3 times 2i. That's going to give us negative 2i times I is I squared times the square root of 3. All right, so now let's simplify. Remember that I squared equals negative 1. All right, so, and then we'll start combining terms. So 6 square roots of 3 plus 4i square roots of 3 minus 3i square roots of 3. And now this would be minus 2 times negative 1 square roots of 3. So that's going to make this 6 square roots of 3 plus, right, that's two negatives, 2 square roots of 3. We can add those together, and then plus 4i square roots of 3 minus 3i square roots of 3. I won't put them in parentheses this time. So we can combine these two, the numbers, plus these two, the imaginary terms. So the reals plus the imaginaries. So 6 square roots of 3 plus 2 square roots of 3 is 8 square roots of 3. You just add the coefficients, just like if it was 6x plus 2x. And then 4i square roots of 3 minus 3i square roots of 3, well, that's just 1i square roots of 3. Now I don't have to put the 1, I'll just put I square roots of 3. And there's our answer. All right, so it's a few steps, but just, you know, not difficult steps, and just keep care of your terms, and make sure you simplify those radicals first. Because if we were to call negative square root of 3 times a negative 4 12, square root of 12, that would have been wrong, right? Right, this times this is not going to be the square root of 12. We have to simplify out those radicals first. Right? Simplify those negatives, right? And really, why would we leave the square root of 4 when it's 2? And that's the end of my podcast. Thanks for watching. Bye for now.